Hey class, we're going to start this video by going over the two examples that we ended the previous video with. We're going to be looking at examples for the goods market in the Keynesian ISLM model. The first problem I had you guys do is what happens if expected profits decrease. Now we know expected profits is in the function for the investment in the firm side. Well, we need to see expected profits decrease. Would investment increase or would it decrease? Well, investment would end up decreasing. And when investment decreases, the expenditure will also decrease. So the expenditure line 1 would tilt downward. Or, for simplicity's sake, shift downward. As long as you know that the autonomous consumption does not change. Okay? So, expected profits decrease, which decreases investment, and thus decreases expenditure. This will decrease the expenditure line, causing the expenditure to fall, as we see down here, to E2. And we also see income GDP fall. The next problem I had you guys look at is what happens if the stock market increases. So the stock market is a part of the consumer confidence. So we're reading the stocks, we're thinking, oh, this is pretty great. So if the stock market starts going up, we have a general sense that the economy is trending in a positive direction. So this will be embedded in consumer confidence. Consumer confidence is embedded in consumption. So we increase consumption, which increases the expenditure. When expenditure increases, we know that this line will shift up. When this line shifts up, we find the new equilibrium where it crosses the Keynesian cross. Y2 shifts to the right, and we see an increase in expenditure. Okay? Pretty simple. Just remember those relationships in the investment and consumption functions. The next topic in this video we're going to discuss is the Keynesian Multiplier, which basically says if there's $1 spent in the expenditure, this will create more than $1 in GDP. So a change in expenditure is less than the ultimate change in GDP. So what you can see is this is pretty similar to the deposit multiplier that we talked about in the classical model. So $1 spent with a marginal propensity to consume at 0.9 creates this rolling down a hill effect. $1 spent will lead to 10 cents saved and 90 cents spent. The second person then has 9 cents saved and then 81 cents spent. And it goes on until infinity. We can also write this as a change in GDP over the change in government spending is equal to 1 over 1 minus the marginal propensity to consume. So basically, the larger the multiplier, the more that is spent. So let's do a quick example. If the marginal propensity to consume was 0.5, which means you spent half and you saved half, we would get a multiplier of 1 over 1 minus 0.5, and this turns out to be 2. Then, if we do a marginal propensity to consume of 0.8, we can find a multiplier 1 over 1 minus 0.8. This turns out to be 5. So you get 5 times the amount you initially spent when you have a consumption of 0.8. Because when you consume more goes into the expenditure, and thus more GDP comes out. Because we have this rolling down the hill effect until it reaches infinity. So this would be the moment where I'd say, hey, pull out your calculators. Do these questions for me. But that's okay. Just keep going along. And then the main topic we're going to be talking about today is the IS curve and how to derive it. So the IS curve is the investment and savings curve. And the definition for this is the IS curve combines the interest rates and output such that the goods and services market is in equilibrium at any possible equilibrium. So this means as we change the interest rate, what happens to the output and how can we graph that? So we're going to derive this using the goods and services market and a movement of the equilibrium curve. Now we're going to allow the interest rate to change. We're not going to be in ceteris paribus at this moment. But once we do go into ceteris paribus, where we hold the interest rate constant and only move the goods and services market, then that's when we create a shift in the IS curve. So right now we're deriving it when we allow the interest rates to change. Okay. So now we're going to derive the IS curve, which this is my fourth take since my dog keeps barking, which it's totally fine. Here we go. We're going to derive it based upon the goods and services market. What we're going to do is stack the ISLM graph underneath the goods and services market graph to make sure we have a good visualization. Now we can do this because the x-axes are both Y, or income and GDP. So here in the ISLM market, the y-axis is interest rates. So let's assume that our interest rates fall. So as interest rates fall, what happens? So this is my basic what happens when question that I always do in class. So what happens when interest rates decrease? Well, the first thing we're going to do is map out our original interest rate point to our original income slash GDP. So let's pull down our income, or Y, Y1, and let's say our interest rate is at R1 right here. Now, as we see interest rates fall, what happens in our E equals C plus I plus G equation? So when interest rates fall, that means consumption will go up because people will start taking out more loans. Investment will go up for the same reason. And then overall, expenditure will rise because we have two increases in the equation. So when we see a rise in expenditure, we know that the expenditure line goes up. So let's draw that in. Now we're at expenditure line number 2. So let's map this down. We know that interest rates fell, so let's say they fell to about right here, R1. And we know this is our new equilibrium at E1, or E2, sorry, and Y2. But now we're going to pull the Y all the way down to Y2 and make it the spot where it crosses. So here we know that two dots can make a line. And this is our IS curve. So, as interest rates fall, consumption increases, which leads to an increase in expenditure, and also investment increases, which leads to an increase in expenditure, and both of these lead to an increase in Y. So as interest rates fall, output increases. Okay? So this is how we derive the IS curve. We allow interest rates to move. As I said previously in this video, when we say what happens if expenditure moves, ceteris paribus, which means all else equal, then we'll have a shift in the IS curve. Okay? So by deriving, we allow the interest rates to fluctuate. By saying, what if something else happens in a different graph, then we hold the interest rates constant and we shift the curves. Okay? Alright, now we're going to do a few examples. So let me just erase this board and get some up. The first example we're going to do is what happens if taxes decrease. Now we know taxes are within consumption. Remember, consumption is A plus B times Y minus T. So T is the taxes. So if taxes fall, then consumption will increase because they have an inverse relationship. Now, when consumption increases, we know expenditure will increase. So we've already done stuff like this. What happens? The expenditure line rises. So let's draw that out. Okay, so we see an increase in the expenditure, and we also see an increase in our output, or GDP/income. Okay, so when we see an increase in consumption that leads to an increase in our expenditure, well, what happens to the IS curve? It'll shift to the right. Okay, so this will be IS2. So remember, if the expenditure curve shifts up, the IS curve will shift to the right. If the expenditure curve shifts down, the IS curve will shift to the left, because we're keeping these Y's and R's and E's all in equilibrium. The goal is to keep the economy in equilibrium. Okay? So when we're doing these examples, remember, anything that impacts C, I, or G, other than a change in R, will shift the IS curve. If it's a change in R, it'll be a movement along the IS curve because it's a representative of the y-axis. This is the same for supply and demand. Okay? The next question we're going to be doing is what happens when government spending decreases. So this one is very interesting because we have a decrease in government spending, which will decrease our expenditure, and we know when there's a decrease in the expenditure, we're going to shift, or tilt to be correct, this line down. Okay, so we're going to see a new equilibrium at Y2 and E2, and like I said previously, if the expenditure curve shifts down, the IS curve is going to shift to the left. So what you really need to be able to do is pinpoint, okay, what changes in the model in the goods and services market? Then we could go and say, okay, the goods and services market changed. Now how does that impact the IS curve? So if the expenditure equation shifts down, we're going to shift the IS curve to the left. Okay? So as government spending decreases, the expenditure will decrease and shift this to the left. And we will discuss this more in detail because it's actually something called crowding out, which we'll work on in a little bit. So if you have any questions with these examples, please let me know because we're just going to keep going and start stacking more graphs together. In the next video, we're going to look at the money market and how that derives the LM curve. Okay, so let me know if you have questions.